Good morning, Algebra 1. So we've reached week 8. This is going to be the last week that I assign any new work. Um, we're just going to kind of move forward to the next section. I want to give you guys as much exposure to different things as possible since we're losing a little bit of content with the online learning. Um, so as is usual, we'll have online learning slides and online learning slides due Wednesday and another assignment due Friday. We're going to be doing something a little different this week. We're going to be using Google Forms instead of just online learning slides and worksheets. So this is section 6.5, and it's all about linear inequalities. We've learned about linear equations, slope-intercept form, point-slope form, standard form. We've learned how to graph things. We've learned how to check points. So this really isn't going to be too different, so it's not going to be too difficult. The only thing that's changing, as you probably can already see, is instead of an equal sign, it's an inequality symbol. Okay, so the first slide, which you're going to have in your online learning slides, is going to be very similar. I'm going to give you a linear inequality, and I'm going to give you an ordered pair, and I'm going to ask you, is this ordered pair a solution? We've done stuff like this in the past, where you're essentially doing a check. Okay, I don't want it to be capitalized. So the process is pretty much the same. Instead of a y, you're going to replace it with a 2. And instead of an x, you're going to replace it with a 1. The only difference is instead of an equal sign, you want to make sure that you're carrying this greater than symbol throughout. So this looks like an equation in slope-intercept form, y equals mx plus b, but it's y is greater than mx plus b. And all we're going to do, just like we've done in the past, is evaluate where we see operations. So I'm going to evaluate this 1 minus 3, and that's going to give me negative 2. Now, just like we've done for checks in the past, when you get it down to one number on both sides, you just read the statement to determine if it's true or false. Now, you have to be careful with inequalities. Just because the numbers don't match doesn't mean it's false. Likewise, just because the numbers do match doesn't mean it's true. You have to remember that this is an inequality. There could be a range of solutions here. When I read this, this says 2 is greater than negative 2. And ask yourself, is that true? Is a positive 2 greater than a negative 2? And of course it's true. In fact, all positives are bigger than negatives. So because this is true, the point 1 comma 2 is a solution. We're not going to say it's the solution because there, again, could be a range of solutions that work because this is an inequality. Let's try the next one. It's the same, inequality. Y is greater than x minus 3, but instead of y this time, I'm going to replace it with negative 7. Instead of x this time, I'm going to replace it with a negative 3. And this minus 3 that was on the end has to come down for the ride. So it could be a little misleading because I'm substituting a negative 3 and there's a negative 3 for the b value. And again, I'm just going to evaluate where I see operations. Negative 3 minus 3 more, signs are the same, so I combine and I match the sign of the things I'm adding. I get negative 6. And once I've got it down to one number on both sides, I just read the statement to determine if it's true. This says negative 7 is greater than negative 6. So we ask ourselves, is this true? And the answer is no. Negative 7, because these are both negatives, this is actually false. Okay, if they were both positives, yes, it would be true, but you have to remember negatives work backwards. So this ordered pair is not a solution. Okay, so you're going to have a slide just like this, and this is all you're going to do. You're going to plug in the values for x and y, evaluate, compare. If true, it's a solution. If false, it's not. Now let's get into the real nitty-gritty of this section. And the majority of section 6.5 is graphing linear inequalities and writing linear inequalities. So I've broken it down into a few steps. Step 1, and most of these inequalities are going to be in slope-intercept form just for the sake of time and ease because we're not really going to have a lot of time to delve too deep in this section. So it's all going to be in the form y equals mx plus b with the exception of vertical and horizontal lines. So step 1 is going to be the same as always. If you were plotting an equation in slope-intercept form, these are the steps that you would follow. So step 1 is not different from what we've done in the past. Step 1 is you're going to use B to plot the y-intercept, and then you're going to use M to plot additional points. Typically 2 is best. For inequalities, though, you want to plot as many points as possible. So I'm actually going to add that. Plot as many points as possible. There's a reason why we want to plot as many points as possible. There's a reason why we want to maximize the amount of space that line is taken up for our graph. Because when we get to steps 2 and 3, that's going to affect how our graph looks. So step 2 is where things start changing. As you can see from the previous example, this is not an equal sign. It's an inequality symbol. That type of symbol is going to determine the type of line you have. If you have a symbol like this or this, so the inequality symbols without the bar, you're going to connect your points with a dashed line, okay? So something that kind of looks like this. Let me actually put one here so you can see it. It's going to look like this. Let me get some arrows on there. Make it a little thicker so you can see it. Change the color even. Whoops. It's going to look like this. It's going to be a dashed line, okay? If you have a symbol, and I'm just using the underline feature here, that looks like this or this. You're going to connect your points with a solid line, okay? So it's essentially going to look like the same type of line we've always done in the past. It'll be solid like this. So if the symbol that you're looking at, regardless of which way it's facing, if it doesn't have a bar, you'll use a dashed. If it does, you'll use a solid, okay? Step 3, when we're graphing linear inequalities, you're going to shade a region of the graph. And in order to determine which region, there's 2 ways to do that. You can do it algebraically by plugging in a point and checking, or you can use the shortcut method. For the sake of time, I'm going to show you guys the shortcut method. If you're looking at an equation, or excuse me, an inequality, where y is greater than or equal to, just some sort of greater than symbol, okay? You're going to shade above, capitalize that, above the boundary line that you've graphed. If you have y is less than, or y is less than or equal to some sort of less than symbol, you're going to shade below the boundary line, okay? So some of this might not make sense right now until I start graphing them. So this is where your online learning slides are going to deviate from my notes. I'm going to actually graph these inequalities all the way through. When you get to this point in your online learning slides, you're going to be taken to a Google form. Please read this carefully. Look at what it's going to say. You get 1 attempt at completing this form. Once you do it, that's it. You can't go back and redo it. And the only reason that it's set up like that, that's just due to the nature of Google Forms and Google Classroom. If I want to import your grades into Google Classroom, I have to make it so that way it's a one and done attempt. So please make sure that you do not click this form until you've watched this video all the way through and you feel comfortable with the material, okay? So let's go ahead and do some examples. Y is less than, that's how we would read this, 3x plus 5. Step 1, plot the points. So I'm going to do it kind of like we've done in the past. I'm going to take my line and I'm going to go to my y-intercept first, which is 5, and then I'm going to take my other arrow and use the slope to plot more. I can't go up 3 and to the right 1, so I'll reverse both directions. Down 3 and left 1. And remember, we're going to do this for as many times as I can. Now on your Google form, this is all going to be multiple choice. You're not going to have to do this part, but I'm going to show you how to do it so that way you know how to pick the correct answer. So I've plotted my points. Now I need to figure out what type of boundary line do I need. Do I want a dashed line or do I want a solid line? Well, you look at the symbol. If it doesn't have a bar underneath, it's a dashed line. So I'm going to go in here and make it dashed. And then the last thing that I need to do is I need to determine where to shade. Do I shade above this line or below? That's when you look at the Y in the symbol. If it says Y is less than, any type of less than symbol, you shade below the boundary line. And the easiest way to figure out what's below, put your finger or pencil or cursor on the line and move vertically down. So that brings me to this region of the graph, and it's this entire region that gets shaded. Okay, so this is going to be a little tricky to do electronically, so I'm going to do my best here. Uh-oh. There we go. It's not going to be perfect, but this entire region is getting shaded. Let me see if I can move a little bit. There we go. It's not beautiful, but it is what it is. It's a lot easier to do this with pencil, as you guys can probably see. So if I was doing this with pencil, I would just color in this entire, here, let's do that, this entire section of the graph. It would be completely shaded, okay? Let's do another one. Y is greater than or equal to negative 1/3 x plus 2. Step 1, plot my points. My b value is 2, so I'm going to start there on my y-axis. My slope is negative 1/3, so I can go up 1 and left 3, up 1 and left 3, or I could go down 1 and right 3. And I do that for as many points as I can do. Step 2 is you want to graph the boundary line. So I want to determine what type of line I need. Do I want a solid line or a dashed line? Well, my table said that if I have a bar underneath, I want it to be solid. So I'm just going to leave it like that. And then step 3 says determine where to shade. If it's y is greater than or y is greater than or equal to, you're going to shade above the line. So the easiest way to do this is put your finger or pencil or cursor on the line and move vertically up. This puts me in this entire region of my graph. So that's the area I'm going to shade. So again, it's not going to be perfect. I'm going to do my best. If you were doing this on paper, you would just color in this entire region. So this entire region of my graph would get shaded, okay? Let's try another one. Y is less than or equal to 4. So if you notice, I don't have an X. If it's only Y, you fly. It's a horizontal line, meaning it's left and right. So what I need to do is I need to find this value on the Y-axis. Here it is. And just pull a horizontal line across my graph, just like that. So my points are technically plotted. I just want to make sure that my boundary line is graphed appropriately, meaning do I need a solid line or a dashed line? Well, I've got a bar, so I leave it solid. If it was without the bar, I would have to go back and make this dashed. Next step is to determine where to shade. If it's y is less than, you shade below. If it's y is greater than, you shade above. This is less than, so I shade below. And again, you put your pencil, finger, cursor somewhere on this line, move vertically down. So this entire region below the line gets shaded. And luckily, since this is essentially a rectangle, it's going to be a little bit easier to shade. Here we go. Make it pink, whoops, and take the outline off. So everything below gets shaded. I wish I could make it a little see-through. All right, number 5, x is greater than -3. So there's no y this time. So this is another special line, but instead of being horizontal, this is vertical. Okay, it's an up and down line. So I want to find this number on this axis. Here it is, -3. And I'm just going to make this line vertical. And I'm going to drag it all the way through my graph. Really maximize the space here. Okay, so technically my points are plotted. I just want to make sure that the boundary line is graphed correctly. So if I look at this symbol here, it doesn't have a bar. So I don't want a solid line. I want to make sure that this is a dashed line. No bar means dashed line. The shading is a little bit different for when it's just a vertical line. You can kind of think of it as like a number line. If we were graphing this on a number line, we would do an open circle and we would shade to the right. Same idea here. This dashed line is like our open circle, and then we shade everything to the right of it. So if it's greater than, x is greater than, we shade to the right. If it's x is less than, we shade to the left. So just think of the number lines from back in chapter 3. Pink and transparent for the outline. Okay. So that's graphing linear inequalities. And again, yours will be multiple choice. But again, don't click the Google form unless you're comfortable with this material. Let's go the other way. I've given you a graph. You're going to have to write the boundary line. So again, this will all be multiple choice, but you need to know how to do it in order to select the correct answer. So step 1, we're actually going to write this as an equation, just the same as we've done in the past. We're going to look at just this line here, and we're going to write an equation for it. Okay, so y equals mx plus b. So when I look at this, my b value is, actually let me do it here. My b value where it crosses the the y axis is -4. And then I just pick another lattice point. Here's a good one, and here's a good one to determine what the slope is. So it's obviously got to be a negative slope because the line's falling. I go down 1 and then to the right 1, 2, 3, 4, 5. So it's -1/5 for my slope. So once I have that, I can just put it together in the form mx plus b. Let me just erase all this. So instead of m, it's going to be -1/5. And instead of b, it's going to be -4. So that would be the equation version of this line, right? Now we need to determine what type of symbol do we make this. Do we make it like this? Do we make it like this? Or do we do one of those symbols but put a bar underneath it? Okay. The first thing I like to determine is, will I need a bar or not? That's when you look at whether or not you have a solid or dashed line. If it's a solid line, which it is here, you're going to use one of these symbols. So I know that I've got to use one of these with the bar. To determine which one, you look at where the shading is, okay? So if I put my cursor on this line here, you're going to move vertically until you reach the shading. If you move up, you're going to pick the greater than symbol. If you have to move down to reach the shaded region, you're going to pick the less than symbol. So if I put my cursor anywhere on this line, I need to move vertically up above that line in order to reach the shading. So I want the symbol that is greater than or equal to. So to recap what I just did here, I wrote the equation in slope-intercept form like you've done in the past. I found the b value, I found another lattice point, and I determined the slope from the b value and another point. I put it together in y equals mx plus b. I knew to put a bar underneath my symbol because it was a solid line, and I knew that it needed to be greater than because the shading was above the line. Let's try another. All right, so same thing. I'm going to determine my b value. It's right here at -2. And then my m value, Let me just go from B to another lattice point. It looks like there's one right here, and right on the x-axis, and all the way over here, there looks like to be another one. So I'm just gonna go to this one over here. Again, it's a negative slope because the line's falling. I go down 1 and right 1, 2, 3. So my slope is -1/3. So I'm going to actually write that as an equation first. Y equals -1/3 x, and then my b value is -2. So now I need to make sure that I fix this, right? It's not an equation because there's shading here, and I can tell that it's not a normal equation due to the type of line they're using, so I know I need some sort of symbol. So because it's a dashed line, I know that I have to use one of these symbols. I have to use one of the symbols that does not have a bar, right? And then to figure out whether or not it's y is greater than or y is less than, same idea. You put your finger or pencil, whatever, on the line and you move vertically until you reach the shading. So in order to reach the shading, I have to move down. So that means that I want to pick the less than symbol, okay? So it's got to be less than. Let's do another one. So this is a vertical inequality. So this is going to be in the form x equals. That's how you would normally write this equation. It would be x equals, and then the value that it passes through, which is 3. Okay, so it's x equals a number because it's vertical. So again, these are, going to need the bar underneath because we have a solid line. That much I know by just looking at the line, right? It's solid, therefore I want the symbol with the bar underneath. And then to determine whether or not I want x to be greater than or less than, I look at where the shading is. Again, think of a number line. I would have to move to the right in order to reach the shading. So if this was being graphed on a number line, we would want our variable to be greater than 3. Another nice way to think about it is look at the numbers that are being shaded. Are these values greater than 3 or less than 3? And the answer is 4, 5, 6, and so on. Those values are greater than 3. So I want the greater than symbol. And again, I want the symbol that has the bar. Okay. And then last but not least, we've got a vertical inequality. So when it's, or excuse me, a horizontal. So when it's horizontal, it's going to be y equals a number without an x. And it's got to be y equals whatever number it passes through on the y-axis, which is -2. I need to determine whether or not I use the symbols with the bar underneath or not. This is a solid line, so again, it's going to be either a symbol like this or like this. So to determine which one it is, put your cursor or pencil on the line and move vertically until you reach the shaded region. I had to move down to reach that shaded region. That means the shading is below. So I'm going to choose the less than or equal to symbol. Okay, so we've covered quite a bit, but I'm hoping that because everything's multiple choice and I'm keeping the inequalities fairly simple, that you'll have an easy time with the multiple choice questions on your Google form. So go ahead, give those a try. Again, don't do it until you feel like you're ready, because it's a one and done thing. We'll have a Google form for Wednesday in addition to whatever slides you had to complete, as well as another Google form, same type of format, which will be due on Friday. Okay, reach out if you have any questions, and don't forget to click turn in for your Google slides when those are done. Take care, everybody.